Hello everyone and welcome to powder mixing experiment calculations and data analysis. Our objectives include the study of the efficiency of a cube mixer, the study of the effect of time on the homogeneity of the resultant mixture, but our main objective is to estimate the optimal mixing time for 5% weight per weight mixture of sodium salicylate in lactose with particle size less than 1 mm prepared using a cube mixer operated at 25 rpm. To estimate the optimal mixing time, we need to construct mixing profile. Mixing profile is a plot between the coefficient of variation versus mixing time with a suitable time units. Coefficient of variation is also known as a relative standard deviation, which is equal to the standard deviation divided by the mean times 100%. Then we will need to do what? To calculate the mean and the standard deviation of each 5 samples at each time. This should be done via calculating the concentration of each sample. Then we have to start with constructing our calibration curve. Remember, the concentration of the stock solution we prepared during calibration curve construction was 100 mg/cent weight per volume. To calculate each standard solution concentration, please calculate first the dilution factor. Then the standard solution concentration will be equal to what? To the stock solution concentration divided by the dilution factor. Remember to use Excel equations and properties properly. Now, plot the absorbance of standard solutions versus their concentrations. Select scatter chart from your insert menu. Add the chart title and the axis titles. The chart title should be Calibration Curve of Sodium Salicylate in Distilled Water at lambda equal the lambda you used to prepare or to measure the absorbances. Y-axis title is absorbance, as we did put the absorbance values, versus the concentration, which is the x-axis title, the concentration milligram% weight per volume. Now, please use Excel options to add the trend line. Remember, the trend line should be linear. Keep in mind that we will need the trend line linear equation, and also please display the R square. Now, you need to arrange your data in a similar table as you can see. Mixing profile or mixing samples should be arranged according to the time. First, you will need to calculate the concentration in milligram percent weight per volume for each sample. This should be done using the calibration curve equation. Here, our equation is y equal to 0.0285 times x minus 0.067. Y represents the absorbance value. Meanwhile, x represents the concentration value. And the concentration unit should be milligram percent weight per volume. Again, because the calibration curve from which we extracted the equation was plotted using concentration in milligram percent weight per volume. Remember to multiply the concentrations by dilution factor when applicable. Some samples will need to be diluted. Which samples? Samples with absorbances more than 1.2. Here in our example, we have 2 samples that have been diluted. Now, we need to calculate the concentration milligram percent weight per weight. Remember, 200 milligram sample was dissolved in up to 100 ml distilled water, which has been analyzed using UV spectrophotometric analysis, and the absorbance was measured. The absorbance was used to calculate concentration in milligram percent weight per volume using the calibration curve equation. Milligram percent weight per volume means that x milligram of sodium salicylate is there in 100 ml of the solution, which means the same volume we dissolved our sample in. That means that the percent of sodium salicylate in the original sample was equal to x milligram divided by 200. This would be the concentration in milligram percent weight per volume. Generally speaking, to calculate the concentration milligram percent weight per weight, regardless the sample size and the final volume of the prepared sample, you have to divide the concentration in milligram percent weight per volume by the amount of sample in the final volume of the concentration times 100%. For example, if our sample was dissolved into up to 200 ml distilled water, we need to calculate the amount of sample in 100 ml distilled water, then use it to calculate the concentration milligram percent weight per weight. In our hypothetical example, the weight per weight concentration in milligram percent will be the concentration in milligram percent weight per volume divided by 100 milligram times 100%. Remember, this will be the correct way to calculate it if the final volume was 100 ml of distilled, was 200 ml of distilled water. But here, because our sample was 200 milligrams and its final volume was 100 ml, then the concentration in milligram percent weight per weight of each sample will be equal to the concentration in milligram percent weight per volume divided by 200 times 100%. Now, use the Excel function to calculate the mean value, the standard deviation value, and the variance. Then, the coefficient of variation will be equal to standard deviation divided by the mean times 100%. Now, the time to construct your mixing profile. Again, use scatter charts, but this time with smooth lines and markers to plot the mixing profile. Select the sampling time in minutes and coefficient of variation, and plot them using, again, scatter chart with smooth lines and markers type. Now, add the titles, chart title, as well as the axis titles. Here, in this video, variance in coefficient of variation is mistakenly used. Please use coefficient of variation instead. Now, time to build up your portfolio pages. Use your prepared document, Word document, with the appropriate heading and layout. Now, just copy and paste Excel tables and charts. Always start with results tables, then calculations and data analysis. Remember that types of mixing profiles are non-segregated and segregated. Non-segregated mixing profiles will show either plateau or slightly decreasing terminal phase. Always add the curve tangents to get the optimal mixing time, while segregated mixing profiles shows increasing terminal phase to indicate that the relative standard deviation or coefficient of variation is increasing upon mixing, which means that we are losing homogeneity due to segregation. Here, find curve minima to get optimal mixing time. Please, to see that how to add the tangents, check your PPT student manual page 9. Here are some questions for you to answer. Coefficient of variation or relative standard deviation represent a standardization of standard deviation relative to the mean value, and RSD value cannot be replaced with the standard deviation because we are generating samples of different means values at different mixing times. In the third question, you have to first calculate the amount of sample in 1 deciliter, then to divide the concentration weight per volume by the resultant amount in 1 deciliter. Random spot sampling, 5 samples. Sampling is an integral part of mixing because at any time spot samples generate the data necessary to evaluate the quality of the mixture. The data for statistics are generated by assaying the active ingredient or ingredients in a number of random samples taken from the blend at specified time. Thank you for watching.